Welcome everyone. Welcome to the training demo on Certified Kubernetes Administrator. Thank you so much for everybody joining. So let's continue with our demo today. Agenda for today quickly, right? So prerequisites to understand your Kubernetes first of all, and then as part of it, we'll be discussing what are containers and why containers are required. What is Docker? In fact, we're going to discuss a little bit about it. And then why do we need a container orchestration? Because Kubernetes being a container orchestration tool, so we need to know why container orchestration is required. And after that, we'll introduce you to the Kubernetes, and then we'll quickly discuss about the Kubernetes architecture, and then Kubernetes terminology, and then why exactly we need to choose Kubernetes. Why not any other container orchestration? So we'll quickly compare a couple of things with the Docker Swarm versus Kubernetes also. And then why do we need to go for a certification on Kubernetes? That's also we'll try to discuss. And then finally, we will end the demo with a sample demo, a simple demo that we'll be looking at. This is the agenda for today. So let's continue. So coming to this team, so what are containers basically? So in simple words, team, containers are a way to host an application in multiple environments, such as your dev, QA, IAT, prod, etc. So how a container has become a way to host your application. So what are the various ways we actually use to host the application? Now, why we are opting for containers? Now let's try to understand a little bit about this so that you would get a clear picture why we need containers at this present trend in the market. Now containers are being the buzzword in the market right now. So let's understand why containers are become a buzzword, why exactly they are there. So let's try to compare how we used to host the application earlier and then why we are shifting towards these containers. So just for this one too, I just brought something here like this. So we know that the developers will be developing the source code, which would be normally available in a source code management tool. And then we take the source code, or as a DevOps engineers, maybe they take the source code, they build the code to produce a WAR file, kind of an executable file that can be deployed onto an environment. So now before the containers, how we used to deploy these applications, nothing but your WAR files or ER or any executable files. Now, if you take this, the application deployment needs an environment to run it. So that is where we have a various environments such as dev, QA, staging, and production. The production is being accessed by your end users always. Now, before we deliver it to the production, we always host into multiple environments also, just to certify the application is effectively built successfully, and all these things we'll take into the consideration. We perform various testing to ensure that it is meeting the client requirements. So let's take that before containers, we build the application basically, and we prepare these different environments to host these applications, such as a dev environment requires like whatever the dependencies required by your application, such as a web server or a Java based application requires Java, and then a machine with operating system. Now in different environments, we have these settings or prerequisites to host your application or deploy your application, right? So we take the WAR file, nothing but your application code, and we deploy this code completely into different environments, right? So means the prerequisites to deploy this application are built separately in every environment, and we take only the application, which is nothing but your executable file. For example, in Java case, it's a WAR file or a ER file, which will be deployed onto different environments, right? Like dev, QA. So the environment that you see is pre-built before we deploy an application there. Now that is how we used to do it. Now this way of deploying, for the few couple of decades now, we are following the same thing. We used to face a lot of issues here. The first and foremost is that the application may work in your lower environments, but might give some problems in the production environment. Now this is where the blame game starts, like when we have a production outage and we call everybody into the call, and then finally we call the developer and say that okay, the application is not working. The developer quickly comes and he tests his application in his own environment and says the application is working fine in my environment. Now you need to troubleshoot the issue why exactly it is not working in the production. Now this takes a longer time, leads to a downtime. Now this is where the blame game also starts. between the developers and the operation teams. Now there's a lot of challenges, a lot of problems. There could be a lot of reasons here why the application works in development, why not it works in the production. Because everything is carried out differently, right? Because we have different systems in different environments. Every dependency required to run your application is being separately deployed or separately hosted in different environments. Now there could be a chance that we always or we may miss some configurations in different environments that would lead us to a production outage. Now this is the main problem basically which we had it so far the few decades which you are deploying the applications in this format. Now we would like to overcome this problem, right? That is where we introduce you to the containers. Basically the containers are a way to host your applications with all its dependencies. The same thing if you look at with the containers, what a container says or what does a container have in it basically is it says that you should not deploy only the single application file and prepare the environment separately. Now let's prepare a package. Let's prepare a package or a container, you can call it, which has your application plus all of its dependencies in it. Now, if you take an example here, so we prepare something, a package which has a var file in it, and along with it, all the dependencies to run this application, like the Tomcat server or Java, whatever it is, and the OS dependencies, everything we need to package it together as a single package. Now we want to run this package. Technically, this would be called as an image, right? So that image we want to deploy into a different environments. Now this is how we could resolve the issue that it is not working fine in production, but it is working fine in dev environment, right? So this way we eliminate the dependencies of hosting different softwares, different dependencies required to run your application in different environments. We build everything as a simple package and we want to deploy this package into a server. That could be a dev server, or that could be your stage, or that could be a production. So if this package works in my dev environment, the same package would work in production also. So this is what we want to do it, or this is what a container definition says to you. The container is nothing but an application plus all of its dependencies packaged in a single container or a single software package, and then we deploy this package as into an environment that would be called as a container. So we prepare this package that technically called as an image, and when you run this image in an environment, that gives a runtime environment where your application starts up and starts serving your end user. So that is the runtime format of an image is called as a container. Now technically image and container are both are same. One is in a sleeping state and another is in a running format. That's all about it, right? Now how exactly I should build this image, or how exactly I should package all this stuff together securely, right? That is where we introduce, or we need something called as a special software which is called as a Docker. A Docker or a containerization platform is required. In this case, Docker is a software, or Docker is a platform basically which allows us to build an image and then ship it wherever you want it and then run it as a container in different environments. That is how we needed containerization in the picture, and this is how we actually do it. Now in simple words, yes, container is a software package which has an application in it and all of its dependencies together inside that one. Now this one we deployed. Now the way we used to deploy the application earlier was to deploy only the var files. Now the containers in the picture, we used to, or we are now deploying the containers as an application deployment. So that is where we introduced the containers, and this would resolve a lot of problems also. Now if you try to understand and why exactly we need it, now we understood that there is a concept that we need to build a container and then deploy it, so that we would resolve the first point of issue, which is a blame game that will be resolved by default. Now along with this, what are the various other benefits that a container brings in for you? Now this is not the only advantage that we look in for, but where are the other advantage? What are the various things that I should be looking into when I'm running or when I'm containerizing my application, or if I want to containerize my application, what are all the things which I need to look into. So that is where let's discuss about more how we used to host these applications, where exactly we used to host these applications. Simply I said that various environments would be there, and then there would be a server, like what kind of a servers we used to use to host the applications over the decades now, right? And now we are using containers can be deployed on a server again, but let's try to understand how this containers brings in more advantages to our latest trending technology and deployments. So this is where let's discuss about a few things, how we used to host an application and what are all the ways we used to, or where we used to host these applications over the years. Now at the first, we started with the computer worlds with the physical boxes, always a physical servers. Now in earlier days, at the first era of IT, we started deploying your applications into a physical boxes, directly the hardware, and then we built an operating system on it. And then we started deploying like Java, Tomcat, or whatever it may be you think. Finally, we deploy your application. That is the first stage of your application deployments, where we used to host an application which is on top of a physical servers. Now, these physical servers usually have an enterprise level. They always have a big fat servers, we call it. They always have a huge amount of resources. Now, why? Because we kept a huge amount of resources here. Now, earlier days, we know that, or we knew that, there is no performance testing for your application, or there is no load testing that used to happen on your applications. We just develop the application, we deploy the application. We never worried about how it is performing well or not, whether it is optimized to utilize the hardware resources properly or not. We never worried about it. Now that is why we used to keep, because we never know how much memory or how much CPU is required by an application. Now we never calculated those things. That is the reason we hosted them on a big fat servers. If it requires things, it takes it. Now if it doesn't require, definitely it will not use it. In that case, we are wasting a lot of resources on every physical box where you host your application. Now because these hardware components are costly, and then that is a direct money involved with your organizations. Now it's a lot of expensive way of deploying your applications in any organization. People wanted to move out of it, or they wanted a better solution to host the applications. They want to reduce the cost, obviously. Now this is where we introduced, or over the night or somewhere in 2000s, over the night we came across a new technology which is called as VMwares, or a virtual machines. Now what exactly are these virtual machines, right? Now the same physical box, basically the same physical box, but we converted that into a multiple virtual machines based on the hardware resources. What do we mean by this? Now as you see it in my screen, basically a same physical box, same set of hardware resources. On top of this one, instead of installing an operating system as making a single system, we want to install a special software here which is called as hypervisor. The hypervisor is nothing but provides some kind of a hardware level virtualization, which allows us to create a virtual machine, a machine which looks like a physical machine, but it's completely virtual, and it has its own set of resources allocated to it. It consumes the resources from the underlying hardware, but it behaves as an independent system on top of a single hardware. Likewise, on top of single physical machine, we could build, or we were building many virtual machines based on the hardware resources that can be allocated to each system. Now if you take an example, the first virtual machine here, while creating a virtual machine on top of any hardware, usually it will ask you like what are the resources that you want to allocate it from the underlying hardware. Like let's say that I want to allocate 10 GB RAM, 8 CPUs, and 100 GB disk for my virtual machine. Now this becomes, out of this 64 GB RAM, 32 CPUs, 2 TB hard disk, I'm allocating a part of resources to this virtual machine. So the rest of the resources are still available for me. Now this hypervisor could let me create another virtual machine with my own configuration, a number of virtual machines that can be created on top of a single hardware. This is why this becomes very popular and very much effective resource utilization that came into the picture. instead of deploying a single application on a single hardware, now on the same hardware on the same physical machine, now we are able to deploy multiple applications. Now multiple applications which are independent of each other. Every virtual machine has its own IP address, its own networking. Everything is separately isolated. Now everything behaves as a single entity. Now, similar to that, every machine has its own operating system, its own IP addresses on top of your single. Now, everything behaves as an independent system. Now, you can enable the networking accordingly, and you could access your different applications on the same hardware. This way, we introduced or we created virtualization, and we started using more effective resource utilization on the hardware which we wanted to, right? So that is where, team, this is what we, and every virtual machine has its own full operating system, just like your physical machine. Now the full operating system means that it gets all the features of your operating system accordingly. Now along with that, I can host multiple operating system on different virtual machines. There is no limitation on that one as well, that we could have only one type of operating system in a one physical box. No, there is no such rules. So we could host different types of operating system, different types of applications on all of them, and then we could create a number of virtual machines based on resources, again the hardware level virtualization that enabled us to use more effective resource utilization. Good. Now, is there anything that we need to improve on this virtual machine side still, right? That is where we need to think about it. Now, because we want to move to the containers, we could look at these virtual machines. Of course, they are offering very good things already, but is there any improvement points that we can discuss on top of this virtual machine? Yes, there are a few virtual improvement points that we could discuss. We still need them to be available so that we can go for more benefits out of your resource utilization and all. Now here I mentioned at the bottom, there are the improvement points that can be looked at the virtual machine side. Now on the virtual machine side, the maintenance is very costly. What by means is, every virtual machine has its own full operating system, right? Which means that it is a licensed one in the enterprise level. Now you have to maintain the patches for it. Maybe a quarterly patches need to be applied. There will be a downtime that comes for this one. Now along with that, you are hosting applications on it. You need to maintain or patch your application softwares, Java upgrades, Tomcat upgrades, whatever you do, everything need to be separately maintained. Now this would require a lot of skill set, means that there is a lot of resources required for your organization. Hence we are spending more resources or more costlier effort. We need to deploy a costlier efforts here to ensure that the VM infrastructure is up and running always. That is one of the improvement point where we need to think about it. We need to avoid these maintenance, which is causing a lot of things accordingly. So that is what we need to look at it. That's the first improvement point which we can think about it. Now the second thing is about boot time. Here, whenever, let's take a scenario here, maybe, right? Whenever we are in a production outage, let's say that you fixed something in a production outage during it. Now you have to reboot a machine to take the changes effect and then resolve the issues. Now if you go ahead and reboot any virtual machine, right, it goes down, it comes up, but how long does it takes to launch your application after you reboot your machine? Now team, try to understand, it's very clear. When you shut down a machine, the operating system goes down. When it starts back, it has to initialize this full operating system here, which means that all the operating system libraries has to be started. Operating system services need to be started first. Then your Java or Tomcat starts or initializes. Then your application loads into the Tomcat server. Then you finally will be able to access it. So this process would take at least 5 minutes in any worst case scenario, 2 to 3 minutes or 4 minutes. But in the point of client, right, it is still an SLA, service level agreements we call it normally. Now that is the downtime that he is getting it, or end user is getting the downtime, so the 4 or 5 minutes. Now you need to pay for this SLS. Now how would I reduce this downtime more? How quickly can I bring up my machines so that there would be no downtime for my end users. Now this is what we need to think about. Also, this is another improvement point that we still need to look at it, how quickly we should be able to bring it up. That is something. Now the third thing is that dynamic resources. What do we mean by dynamic resources here, right? So let's say that the example here again, the virtual machine we created with a 10 GB RAM and then 8 CPU, right, along with that 100 GB disk. Now my application is running inside this virtual machine. Now all of a sudden it required, because there are more number of requests have come to the server. Now it would require, or it could require something called as a 2 GB RAM extra. Can it extend dynamically on its own? There are ways that we can extend it live, but you have to do it manually. But can my VM extend on its own? Now the answer is no, we cannot do that, or VMs cannot go beyond the limits that you give it until unless you won't put it manual efforts again. Now we do not want this one, because this is where at the end it goes to 10 GB, application will hang, and that might crash your system, and that will still get a downtime. So dynamic resources are not possible with your virtual machines. At the same time, again, I allocated 10 GB RAM, but is my application using 10 GB RAM? Maybe it is using only 5 or 6 GB at the same time. The 4 GB is still idle, that cannot be utilized for the other virtual machines also. So there is a possibility that we are still maybe wasting kind of resources at virtual machine side. Dynamic resources, it cannot extend on its own. At the same time, if it is not utilizing it, it cannot give it to other virtual machines sitting on the same hardware. It could be wasting some resources, or it could be not not able to extend the resources. Now this is the problems we have it with the resources constraint. We still need to think about it, how improvement we require. Now that's the third point. I hope you guys are all clear. Now the scalability, the last one is a scalability that you can think about it. With VMs, scalability is possible. Yes, we can scale them, but it still requires a lot of configuration that need to be kept into the place. After you create a virtual machine, I have to, let's say that I want to replicate my production like from 10 servers to 20 servers. First, I need to create virtual machine. You could say that we could build an image again, that would cause a lot of issues. So we go for always creating a new virtual machines, and we place all the things again, like you place your Java, you place your Tomcat, you deploy your application, set up the routing. So there are a lot of configuration that you would take it, that would take at least some time to create a new infrastructure. Scaling up is possible, but it's not as quick as we are expecting in nowadays trends, right? That is what we need to think about it. So how exactly I need to take about scaling factors here. So these are all the improvement points that I would still look at my virtual machines. Of course, virtual machines are great. We are using virtual machines only. Still nowadays, every cloud is provides you only virtual machines. But this could be the improvement points on the application side, when you look at like, how can I provide more dynamic, application or no downtime applications to my clients, right? So that is where we need to think about these improvement points, how quickly I can do these things. Now, this is where the containers have come into the picture. This is why we use containers. Containers gives you a lot of benefits out of these things compared to the virtual machines. No comparison with the virtual machines basically, but they look like same as virtual machine, because you can see that we do have a var file Tomcat Java OS in your virtual machine side. We could see that same on the container also var file Tomcat and dependencies Java and OS, right? So here the main difference the container brings in is that the minimal OS. In your virtual machines, we deploy a full operating system. We need to log into the operating system and then do the stuff. In your containers world, we use a minimal operating system. In fact, they are called as operating system libraries, not a full stack operating system. They are just the libraries that are required by your application, nothing else apart from that. What do we mean by that are required by the application only? Let me give an example here. Now let's think about in a virtual machine case, the full operating system, you are able to log in. You usually have the standard commands like vi editor or top command or ps command, these things, right? Now, if you really think about that, if I using my application, a Java application, if I deploy on top of a virtual machine, does my application use these features of the operating system? No, it will not use it. It will definitely not use it. But why do I require to keep it them inside them? Now that is where team we took out all these such features from a full-blown operating system. Now we keep only the things which are required by your application, which actually is some kernel features only. Those are the things, those are the libraries which are deployed inside your container operating system. Now this just the libraries which are required to run your application only. That is why it is very minimal, which means that there is nothing to initialize on the operating system side in your container, inside your containers. Now that is the reason we say that the containers are lightweight. The operating systems generally, if you think about the container operating system, they are about MBs, whereas in the virtual machine cases, they are in the GBs, right? So here we talk about something called as containers. A container operating system is very minimal, it is very lightweight, and then finally the complete image that you are building becomes lightweight. Now when you start this image as a container, it quickly comes up. Now believe me team, if you design an application properly with a container, that could come up only within 2 seconds. Means you will be able to access your application within 2 seconds at most. That is how you need to design your containers. Now that brings us, that tells us quickly that the boot time issue is already resolved. We can quickly bring up your containers in a matter of seconds. Now when it comes to scale up also, right, because everything is in a package, now I can deploy another container here, which means that this is just a replica of it. I don't need to worry about all the dependencies need to be created again. So easily scalable, I can scale up my infrastructure. Every container acts as an independent container. It could take the request, it can serve the request, and it can solve whatever you want it. So I can quickly scale up my infrastructure. If I take 2 seconds to start a container, it takes the same time for me to launch another 10 containers. So within 2 seconds or whatever it is, I can launch another 10 containers also. Now the boot time is very low, very minimal, and similarly they are easily scalable. You can see that now within 2 seconds we'll be able to launch 10 different instances across your things. That is the biggest advantage that you get it. Now if you talk about the resources point, since we at the containerization level, we provide something called as OS level virtualization. We are not doing your hardware level virtualization here. We call something or a Docker here as a platform for containers, which provides us basically the OS level virtualization, so that your resources, the containers, runs as a process in a machine. Try to think team, the word containers are a not replacement for your virtual machines, neither the physical machines. Containers would run on top of a virtual machine or on top of a physical machine. They could run on top of those two things. Container is nothing but a process that runs on top of a machine, which means that you would have an host OS, and the container is looking like virtual machine here, but this is just kind of a process that runs on top of a machine and which provides all the features accordingly. So this container can take dynamically whatever the resources required from the underlying hardware. Means we are not restricting any resources for your containers. That is why we talk containers are very good in resource consumption. That is what it is. Okay, so containers can take dynamically. If it requires 10 MB, it can take 10 MB. If it requires 100 MB, it takes 100 MB. If it not requires, it leaves that memory, and the other container on the same box, same physical box, can consume the other resources accordingly. So more effective resource utilization is possible with your containers. That is the advantage that you would get it. Now finally the maintenance part. Since this is a minimal operating system here, there are no licenses required, no patches required. You could build this image again with the latest version if you would like in the development environment itself, and you deploy across different environments. So in different environments, you are completely avoiding the maintenance of various softwares such as Java, Tomcat, and your OS also to be different at different environments. So this is all the maintenance is gone. Only the maintenance we worry about now is underlying host OS. That is a simple host OS maintenance that is still required, obviously. So that can be taken care easily with the minimal resources or minimal cost. That is what we can tell you. So this is how the containers evolved, or containers has become the buzzword. Now containers are offering a lot of these features, so that is the reason every organization want to adopt the containers to make more benefits. So that is where containers have become the buzzwords in the market, and then the Docker become another buzzword because this is the reason. So let's get back to the PPT here. Now if you look at, I hope everybody is clear here. If we look at it quickly, sorry. So the containers, that is the reason I said containers are a way to host an application in multiple environments. Now containers is simply a software package that has an application and all of its dependencies inside to run it. Now simply again, containers are streamlined way to build, test, deploy and redeploy the applications on multiple environments. If we keep on looking at it, why the containers are still greater efficiency it bring in, lesser overhead, it reduces very less compute resources will be utilized by your containers, less overhead on the hardware things, and increased portability. Applications can be shipped into multiple environments without any issues. No blame games. The application works in dev, it should work in production also. That is how it is. More consistent operation, that the DevOps team to know that applications in containers will run the same regardless where they are deployed. Better application development, containers support agile and the DevOps efforts to accelerate development and test production cycles. This is why we need containers. I hope you're all clear. Let me know if you have any questions. Okay, so no questions, so let's proceed. So again, the Docker is here a containerization platform that runs on Linux and Windows, and it helps to build, ship and run containers accordingly. Now there are various other container runtimes also team, but try to understand Docker is being the popular one. Docker is being the easy one to build the containers in the market right now. That's why Docker took over all the other containerization tools. In fact, the containers are present for a long time now from the Linux itself. So Docker is an OS level virtualization software that runs and deploys the containers. In VMware terminology, this is acts as your ESXi host if you know it. If you don't know it, leave it. And Docker provides a way to run applications securely isolated in a container packaged with all its dependencies and libraries. We already understood all these things. Let's proceed further. So here, this is where now we are discussing about the containers. That's fantastic. We know that now we can containerize our application and then we deploy our application as a containers. Now, when we go for a huge scale or when we go for a production environment, basically, we think about deploying this into n number of machines, which means that the high availability comes into the picture. So we want to deploy n number of containers and n number of machines. Now, when I'm trying to do this kind of a deployment, how would I control these containers? Because of their dynamic nature mostly, we need a sophisticated mechanism to control these containers or maintain these containers. That is where we introduce you to the container orchestration. The container orchestration mechanism, which allows us to maintain the things. But before that, let's think why this container is required in other ways around. The first point, which I already told you. Now, if you think about deploying them into different environments, which brings us a lot of challenges along with that. So how would we group multiple servers? How would I deploy my containers into multiple servers? That is something we need to do it. Or let's say that different clouds or different data centers into clusters that map business groups or your project teams. How would I build this cluster to deploy the containers? Now, how do I set up networking? How my containers can communicate with each other across multiple hosts? That also a challenge we need to resolve. Now, how do I define my own capacity-based placement policy? This is like when we are deploying the cluster-based applications, we want to deploy a specific application into a specific host, then how would I placement my containers into a specific host, a group of hosts, where it can acquire more resources? These kind of challenges also we need to think about it. Now, how can I automatically scale out? If in case of a big billion day or something like on-demand business, how would I scale up? How would I scale down automatically? This is also one of the challenge which is still facing it. We need to think about that. Now, finally, how do we monitor these cluster and get insights into the resource consumption by different group of users? Which means that whoever is deploying the containers, are they effectively utilizing your resources or not? Is there anything that we could improve on the resource utilization? So how do I monitor all these containers, whether they are up and running, they are using enough resources they require, or everything is in place accordingly? So these kind of challenges that brings in, if you deploy, or we need to think about some kind of a mechanism which provides these solutions for us. Now that is what is called as container orchestration. There are various container orchestration tools in the market which provides these solutions for us on the top hand, which means that you don't need to implement them on separate basis. You could use any of these container orchestration tools to get these features automatically. The tool will help you implement all these things so easily, so that you just need to concentrate on deploying the containers or packaging your containers. That's it. And then finally, these orchestration tools takes care of the deployment strategies, how you want to deploy, how to enable communication, networking, and all these things will be taken care by your container orchestrations tools. Now there are various container orchestration tools as you see it. Every cloud has its own container orchestration tool, like Amazon has ECS, Azure has ACS, Azure Container Services. Google has Google Container Engine. Now, along with that, Docker itself is a containerization platform. So it also gives us a container orchestration platform, which is called as Docker Swarm. And there is one thing which is interested in our course right now, which is Kubernetes. I know team, we have spent a lot of good amount of time on the containers that is required for you to understand about the Kubernetes. That's why we spent a lot of time on the containers first of all. Now we are introducing as a container orchestration tool about the Kubernetes. Now there are various other things also, you could go and check them. So let's introduce now, let's get on to the topic, actual topic for this demo, which is Kubernetes, right? So Kubernetes is simply a container orchestration platform that allows us to automate deployments and management of containerized applications in large distributed computer clusters, right? So example, you already saw this: update, scaling, security, networking, the challenges that we discussed about in deploying the containers, correct? So these would be resolved by this container orchestration mechanism defaultly. So you should use this to implement all those challenges. Now, where does this Google come from? Basically, it was born in Google and it was in-house project itself, but it was donated to CNCF in 2014 as an open source. Right now, Kubernetes is completely an open source project, which is there in the GitHub. You can look at the URL in the below that project. If you would like to contribute towards it, go ahead and contribute it. Now, the language that it is written in is called as Go language. Kubernetes is developed on Go language, and the Docker is also developed on Go language itself. That is what it is. Now, what does Kubernetes means for us? If you ever wonder about it, the meaning of the Kubernetes, it's a Greek for helmsman. The helmsman is nothing but the person who drives a ship, right? A ship. We know that all the containers, in general containers, the fleets go with the containers, everything over the sea, and then delivers to the other end of the geographic. So here it is, the helmsman. That is why you should see the symbol of the Kubernetes also kind of a steering of a ship, basically, right? That is why it is. Now this is the meaning of your Kubernetes. Kubernetes is a Greek for helmsman. Now the helmsman is the person who drives the ship. So we're going to drive our containers with Kubernetes. That's why they kept it like this. Now also we became the lazy people nowadays. So instead of calling Kubernetes as a bigger word, we cut down the 8 letters in between, we set it as K8s. In short, people do call Kubernetes as K8s. So you could call whatever you want. Now, think how does Kubernetes works basically? Let's discuss about it. Now, this is a situation without any container orchestration into the place, how the containers looks like, right? They do their own things on their own, basically. Like taking an example of football team, there is a team, but there is no coach for them. That's why, you know, they play like in the ground. Whoever wants to play the role, they play their own roles, and they can, you know, they don't place properly themselves. So this would lead us to a lot of troubles. Maybe the team would lose it. Now we introduce or we deploy a manager or a coach for them, Now the coach comes here and then, assign or kind of defines a role. Okay, you should do this, you should do this role. Like we have a striker, goalkeeper, and all that guys. So whoever deploys the goal, they would obey their own, role and responsibility. Now this is how we deploy. Our coach comes and assigns the role first of all, then he places them into the proper places or placements. Basically he deploys them into a proper placements so that everybody works on their own thing properly to produce an outcome. The greater result will get it according to the team work accordingly, right? This is how we deploy it, or this is how it just looks like, right? Everybody is a container. Without a container orchestration, nobody knows what to do it. Now when you deploy a container orchestration, everybody gets whatever they wanted, right? Now this is the same concept that you apply in Kubernetes if you think about it. Now here also in a Kubernetes cluster, basically a cluster is nothing but a group of machines, you can think about it, where we want to deploy our containers. In a production level, it is always that n number of machines. So we want to create them as a cluster, or let's say that production environment, we calling it as now Kubernetes cluster. Now inside this cluster, we have a master node or a master machine that controls all the rest of the nodes, or called as worker nodes, you can think about it. Worker nodes are the those who do the work actually, and management node or a master node who delegates the work, or we talk to the master node. This is the in charge. We can talk to the master node for deployment something, and then master node takes care of placing them to the different nodes accordingly who is in the cluster, or master asks that to the worker to work it. Basically this is the same concept that will be easy for us to manage the entire cluster in a production environment. Now any container orchestration comes with the same logic. You should have a master and everybody works as a nodes or a worker nodes, you can think about, or a simply nodes. Now this is where we introduce everybody, or we talk to the master talks to the nodes, and then ensure that everything in the cluster is working as expected, and everybody does his own role. And it also imposes, or it also puts some set of features or responsibilities to each of the container so that they could act upon it accordingly. Now this is a simple Kubernetes architecture, you can think about it, but let's look at more details about the Kubernetes architecture here. The Kubernetes architecture, cluster architecture, you can think about it. So we always talk to the Kubernetes master, which means that we have various components in the cluster, in the master itself. So we always talk to the API server, or we talk to the API server using a client, which is called as kubectl in real world. So kubectl is a client that talks to the server, which is called as API server. Whenever we call about Kubernetes master, the master is about your API server only. It has various components in it for different purposes, but this is how we talk to it. Now the master talks to the nodes for deploying the containers into things. And now Kubernetes nodes also, we have various components and various purposes. Now let's deep dive or dive into this cluster architecture and then try to understand each and every component's responsibility and role so that we could understand more about it. So let's jump in. Now here let's discuss about the master components. First of all, the master components are nothing but these are the ones. So API server, cluster store, controller manager, and then finally the scheduler. Now the API server is the front end to the control plane or whatever it is. You talk to the master, which means that you're talking to the API server. You give a request to the API server. It takes the request from you in a JSON format or a YAML format. And then finally, you give all the instruction to the master, which is nothing but the API server. Now, in turn, API server takes care of deploying them into the cluster. Now, that is the purpose of your API server. It reads your instruction and delegates the work into the various things in the cluster. Now, the second thing is about the cluster store. This is kind of a persistent storage in your cluster to store the cluster data. Whatever the data that you have it, cluster state, whether the nodes are up and running or not, how many containers are running, how many pods are running, all these things will be maintained in your cluster store as your etcd. Etcd is a solution here. It's called as a key value paid database, which places or which holds the entire cluster state at all the time. In fact, if you want to back up your cluster, we just need to back up the cluster store and then we are done. Rest all the components, they do not persist any data with them, so you don't need to back up them also. Now that is the purpose of your cluster store. It is a source of truth for your cluster, which means that it holds the entire state of the cluster at any point of given time. Now similar to that, there is something called as controller manager on the master itself. Now this is a controller of your cluster, which means that it watches your cluster continuously, which means that it monitors your cluster continuously. And if there is a deviation from the desired state, let's say that my cluster should be in this state, now that is called as desired state. If there is a deviation happens from that state, now this controller manager immediately acts upon and then takes care of the desired state values accordingly. So this helps our changes, watches for the changes, help maintain the desired state. That is called as your controller manager. Now finally, the scheduler, we have it on the master, which watches the API server for the new pods, which means that whenever you want to create a new pods, you give a request to the API server. API server asks scheduler to schedule something onto the cluster. So scheduler duty is to find out a node where the pod can be deployed. Pod is nothing but a container here, team, don't confuse. We are talking about the container deployments. In Kubernetes terminology, we call pod a container as a pod. So we'll discuss more about those things, but right now this is what it is. So scheduler schedules or assigns a node where the pods can be run based on certain rules like constraints, resources, and then affinities we can take into the picture, and then we want to schedule our things into various nodes in the cluster. So these are the roles of your master components. I hope everybody is clear here. So let's jump on and then look at your node components. Now, when we are talking about the node components, right, the kubelet comes into the picture. First of all, the kubelet is the agent of your Kubernetes, which is responsible for the communication between the master and the nodes. Means that every node has an agent, which is called as kubelet, that is responsible for the communication with master and then get the pods or whatever it is, the statistics from the master, report back to the master in case of any issues in your cluster or node. Now that is what it is. It creates pod, it reports back to the master, it exposes an endpoint and everything. It watches the API server again for any new coming traffic. That is what it is going to do it. Now the second thing is that the container engine, of course, we need a container platform to run the containers. The underlying container engine is always the Docker most of the time, but Kubernetes can implement multiple container runtimes also, which is called as a Rocket, or there is a CRIO. There are various container platforms which can be utilized for your things, but 99% everybody uses Docker only, so we would implement Docker along with it. Now this is about it. Container engine is nothing but your Docker. And then finally there is something called as kubeproxy. The kubeproxy is the one which is responsible for the networking, which means that after we deploy the containers, we want to access our application that is running inside the containers. So we need to send a request. So when you send a request to it, the network route or networking will be enabled by these components called as kubeproxy, which runs across every node and then which is responsible for connecting to your pods and nothing but your containers here. So these are the main components, because all our applications will be deployed only on the nodes. So this will be present mostly on the nodes itself to connect to this one accordingly. So this is how we can understand the cluster architecture, various components and various roles and responsibilities of each and every component. Now this is more about the cluster architecture team. That's what it is. Now let's jump on and try to understand the terminology that we use in Kubernetes. As I told already, Kubernetes is about deploying the containers. Now the containers are called as here pods. Our pod is the smallest unit that we deploy in a Kubernetes cluster. Let's say that I want to create a container, then I say that I'm creating a pod. Now the pod possess, or pod has some extra features on top of a containers. It is just another layer on top of it. So let's try to read this right. First of all, pods, controllers, services, and storage. Let's try to understand one by one. So let's talk about the pods. So the pods are the basic unit of deployment in Kubernetes. That's what we call it. Now pods run inside the containers. Sorry, container runs inside a pod. What do we mean by that? Now it is that team, we know that in a Docker world, if you ever worked on it, so Docker world, the container has all of its features such as networking or network namespace, the mount namespaces, everything is attached to the container itself. So it has an application as well as and handling a lot of other things to run your application. Now in Kubernetes, we separated that out. So we created the resources required for your container as separate, and then we let the application run inside the container. Means that the container runs your application and the rest everything as you see it on the side, the network namespace or whatever it is, required PID namespaces which are required for your containers to access your things, that will be maintained separately. Now that is why we call it as container runs inside a pod, right? That is what it is. Now as we see that container can run inside a pod, so we can place multiple containers also in a single pod, but we never do that in a real production scenario. You can see that here, the third one, basically you see that there are two containers in a single pod. Yes, we could deploy them. We could deploy two containers into a single pod which uses the same network and everything. So these are called as co-located containers, or called as main container as well as sidecar container. There is a terminology team, so don't worry about this. When we go into the course, we'll learn more about it. But right now, think that a pod runs a container inside it. Now, this pod provides various features for your container to enable more stuff to it. Now, this is why it is called as ring-fenced environments, network stack, kernel namespaces for a number of containers. All containers in a pod share the pod environment only. That is what we do it. Now the pods are temporary team again in Kubernetes. Pod gets created, pod can be deleted, just like your containers get created, can deleted. So pods also the same way, you can create them and you can delete them. And if you want to scale up the application, we really think about scaling up the pods. Don't think that I can run multiple containers inside a single pod that would give me multiple application containers. You can run them, but this is not the right way of scaling your applications in Kubernetes cluster, especially because Kubernetes can scale the pods, but not the containers inside a pod. So in a better world, we always go for n number of pods which run a single containers having the same application in it. So this is how we need to deploy it. When you think about scaling, think about the same image can be deployed as n number of pods. This is how we need to think about it. So again, team, so pods are nothing but the basic unit of deployment. Let's say that I want to run a container, then I create a pod inside my Kubernetes. Think about creating multiple pods. We need to create multiple containers, so we need to create multiple pods from a single image for a scalability and high availability also. Now this is what it is. Okay, so one last thing about the pods, that's all about it. And after this team, now in real world, if I keep on creating an individual pod, that may not help me. So that is why we need to go for a more sophisticated deployment structures where we introduce you to the controllers. Now the controllers actually keep track of multiple pod replicas. Means we can replicate, like whenever we want to create n number of pods from a single image, we create as a controller. So the controller can track of your pod replicas and then provides an auto healing. What I mean to say here is, let's say that I created a 3 pods here, right? And say that as a controller called as deployment controller. And then this will track off these pods. The replica controller or a deployment controller basically keeps track of these 3 pods, which means that the 3 becomes the desired state here. And by any chance one of the pod goes down, the controller has the capability to bring it up automatically. Like you can see that here, let's say that the pod C is gone here. Now the controller looks at it, automatically brings up a new pod, which is D automatically. So this is called as auto healing basically. Now the controller has this feature which is called as auto healing by default. So in a real scenarios, in a real world scenarios, we actually deploy the pod deployment as a production deployment controller. So that is why we need to go for this. Now this also provides another features. We can scale up with a single command. We can scale up to the number of pods we wanted. Let's say that I want replicas is equals to 10, then it can create 10 replicas of the same image. That is called as scaling. Similarly, we can scale down, scale up, scale down can be possible with the deployment controller. Along with that, it also provides us the rolling update and rollback features, which can be utilized for the no downtime applications accordingly. Now, this is the features basically. Now, the basic unit is pods. The next level is always you need to do it as the controllers, which are nothing but a deployment controller, we call it. There are various types of controllers, but we would use this one. Mostly the 90% scenarios, we would use this type of a controller in a production scenario. Now, finally, we can discuss about, we deployed a single pod. We thought that this is not good. Now we deployed them as a controller, which controls the various pods, which provides the various features such as auto healing and scaling and the role updates. Now this is good. The deployment side, we are good. But how do I provide an access to the end user, to my application? That is where we introduce to another topic in Kubernetes, which is called as services. Now the services are nothing but a group of logical set of pods and provides the access to them. Now here team, let's look at the diagram here. You can think that you can access the application within a pod directly using a pod. Of course, you can send a request directly to the pod. Now you can see that, okay, whenever the pod goes down, pod comes up again, or let's say that the new pod has come up automatically. But whenever it recreates a pod, it changes its identity, which means that pod ID gets changed, the pod IP address gets changed. So you would really don't know how to send a request into the new pod until unless you go and check the IP address and then send back to the load balancers. Now that's a long process basically, right? So accessing the applications without a service is possible, but that's not how we should be doing it. Now, how exactly we should do is that we should create a service to it. The service here acts as a load balancer in front of the pods. Just like, you know, wherever you see that this service will map, or this service will send a request to all the pods in the backend, those who have a role called as web. So I send a request to the service, and the service can forward the request back to the number of pods in the backend. Now, what is the advantage here? Now we know that the deployment controller, if the pod goes down, the new pod comes up automatically, right? It means that the pod has a new IP address again. Now this knows all the backends. Let's say that this is gone here. The pod has gone. Now finally the new pod has come up. The service automatically registered this new IP address to the service IP, kind of a load balancer. Now automatically we can send the request again back to the new pod. So this is how we need to access. In a real world, we always have to create a service in your Kubernetes cluster in order to expose your application into the external world. That is how we actually have to access applications. Now, just for a quick recap on the Kubernetes terminology, pods, nothing but your single containers. Deployments or controllers, nothing but a group of pods which allows us the various features such as auto healing, scaling, and the rolling updates. Now, in order to access these pods again, we create a service separately, and then we would send a request into these pods. These are the top 3 level terminology that you would need to understand in Kubernetes. The rest follows on this only. The rest, everything will be implementing on these 3 topics only, revolves around these topics only. So try to understand these 3 topics very well, and then finally you could definitely crack anything in Kubernetes for sure. This is our motto also. That is why we just introduced to these top 3 terminology, and the rest, everything is something will fall in place automatically as you go and learn the technology. So this is about the Kubernetes architecture and the Kubernetes terminology team on the top level. Now, if you think about why I should use Kubernetes only, basically, if you look at the Google Trends on the last 1 year, this is for the last 5 years if you look at it on the top, but for the last 1 year, if you look at it, in last year March time frame, we see that it is around 25%. Now, if you see it in this 2020 time frame, by this time, it rose around 75%, which means that 75% growth in 1 year. Think about that, how quickly the organizations are trying to adopt the containers and then container orchestration as well, right? So this is why the containers have become the buzzword and container orchestration has become the buzzword. Now that is where Kubernetes is one of the top container orchestration tools in the market right now. There is a lot of lack in the market for skill. So most companies are looking for these things. If you learn quickly and then if you put yourself in the technology, then you will be get the best results. That's what I can tell you. Now, if you look at that, why Kubernetes, again, almost all the top organizations uses Kubernetes as a container orchestration platform. Whoever adopting containers, they are going for Kubernetes itself as a container orchestration, since it provides most. And this is completely open source team. I'm telling you completely, this is completely open source. But there are few organizations, those who go for a support on the Kubernetes. That is where they introduce some kind of the cloud-based services such as AKS Azure Kubernetes Service, EKS Elastic Kubernetes Service, GKE Google Kubernetes Engine, and along with that you have something called as a Rancher, that is on the cloud side. If you go on to the on-premise side, there is something called as a Rancher, which provides support on top of Kubernetes, means it deploys the Kubernetes cluster and supports it. Along with that, we have now Red Hat's OpenShift. Now it becomes the IBM's OpenShift again, because IBM bought the Red Hat. So now there is something called as OpenShift also, which manages your Kubernetes cluster behind. And these are all kind of supported tools if you would like to go for it, but they all use the same Kubernetes underlying to it. Now, if you really know Kubernetes, the learning or understanding those tools becomes a very cakewalk for you guys. So try to understand that in that direction. Now, finally, let's look at a quick demo here. I know that I'm keep talking a lot here, but let's quickly look into some practical stuff, and then we can go further. So I have deployed a cluster team just to make sure that you guys not wasting the time here. So I deployed the cluster here. I have one master and then two nodes. So let's look at this. The basic thing, the kubectl is the command line utility to execute anything in your Kubernetes cluster. Let's say that get nodes. Now you can see that there is one master node, the role is master, and there are a couple of nodes. Now there are various system services that we talked about it. We can look at them quickly. Kubectl get pods -- all namespaces would give you the list of the system running services like your API server, etcd, and your scheduler, as well as your controller manager. And this flannel is a networking solution that is required for the communication between multiple nodes. For the pods communicating across multiple nodes, that networking solution is also required that runs as an agent on every nodes. Right, kubeproxy, you know that we discussed it as a node component which requires for networking again. So these are the various things, right? Now, how do I run a simple pod in my cluster quickly, right? So we can quickly run a pod team with a simple command. We can go for the we can go for the declarative model also there by writing a YAML file or a JSON file. But let's go for the command line first of all, and then we could look at them later. So in order to create a simple pod, kubectl run, right? Nginx, or let's say that I want to run a httpd pod, right? -- image, which image you want to use it, and let's say that this is a httpd image. This is still uses your Docker images only team. Don't think like we are creating separate things here, but this still uses same Docker images are converted into a containers. Kubernetes also does the thing. This is a simple command to create a single pod on your cluster. Let's look at that. Now it says that pod httpd got created. This is the name of the pod which I've given. You can give any name there. So in order to list the pods team, we can see this kubectl get pods. Now you can see that there are two pods running. I have run the other pod earlier, so this is there. That's okay. Now the test httpd pod is running it. Now if you would like to know the IP address of the pod, there is a command called as -o-wide. You can look that this pod is running here, the pod IP address and the node where it is running. It means that the pod got scheduled onto the node 2. As I told, master does not do it. Master delegates the work into the nodes, and nodes are the one which actually do the work. So this is where we can see it, right? So this is how you can understand. So now I have created a pod, that's good. But if I would like to access this externally, means that from a browser, if I would like to access my container or a pod in technical terminology, now this is where we actually create a service for it. Means that we need to expose this into the external world, then only we will be able to access it. Now, how do I expose it? Exposing is nothing but creating a service to access the application. Now the command here is goes that kubectl expose pod, the pod name is httpd, right? And you can say that the port number where you are running your container, which is 80, and the type we need is, don't think about all these things team, just look at that we're able to access it or not. Type is equals to node port. There are different types of services that you created. Right now we are creating a node port service here to access your application. So here it is, let's create it. Now you can see that the service httpd exposed, which means that it is now open for accessing outside the world. kubectl get svc service, you can see this. Now how do I access a service? Basically I need to use the port number which can be accessible outside the cluster, and I can use the node IP address, any of the node in the cluster, either this or this or this. So I'm choosing one node here, and then the port number is 31644. Let's get back here. So here it is, 31644, right? Is that the right port number? Right, 31644. Let's see that we are able to get the response or not. Yes, it works, right? So we got the response from our pod, right? This is the HTTPD, basically the default HTTPD response is it works. Now you can see that how quickly I'm able to run a container or a pod inside my Kubernetes cluster. We created a pod and we exposed it also to run it external world. Now this is the advantage that you get it with a single pod, right? Now let's get back to the cluster. Now you saw that this is what it is, but if I remove a pod, basically this does not have an auto healing feature as such or scaling features we can do it. Now that is where we never deploy a single pods in the cluster. We can delete them, delete a pod, httpd as well as test. Let me delete both of them. So I'm going to delete both of these containers or pods in technical terminology. So the next thing is that team, in order to possess more features such as auto healing, scaling, and then rolling updates and everything, basically we need to do a controller deployment, nothing but a deployment. We need to create it. So we're going to do that in a minute. Let's look at it. Similarly, I'm going to delete the service also because it is no more required. kubectl delete svc. The service name is again httpd. So I'm going to delete it. Now we are deleted. So here let's deploy a deployment, basically, which is a combination of multiple pods, right? So kubectl, we can say that create deployment. I'm creating a deployment here, right? Now my deployment name is my deployment, my dep, I'll give it. And the image I want to use is this is a custom image team. This comes from my Docker Hub account, just to prove you that there is a load balancing also works here. Just look at this. This is a custom image which is still available in the Docker Hub. You could use the same thing if you would like. Sample py app, which is a version 1, which I'm going to use it. Learn DevOps and this one. So let's look at this. Now you say that deployment my dep created. Now let's list the deployments. kubectl get deployment. Right now you see that my deployment 0 out of 1. So see team, we did not tell how many pods we created or we wanted here. So that is the reason by default it created only a single pod, right? Now you can see that this is by default created only a single pod because we did not mention any number of pods here. We have a way of mentioning the pods also. Since we did not mention any, so by default it created one. Now this is where we could use a scale command to scale up your number of pods. Let's say that kubectl scale, right? Deployment, right? You can give my dep. Now you can say that -- replicas is equals to 5, right? Right now you see that only one running here. Deployment internally runs the pods team. So deployment controls the pods. You can look at that. It is going to create 5 pods now. Now it says that deployment scaled, which is easy for us to scale. If you say kubectl get deployment, you can see that 3 out of 5 are available right now. If you wait for a minute, now 5 out of 5 should be available, right? So this takes a time because it might be deploying on another node where it might be downloading the image sometime. So let's wait for a minute. Now you see that there are 5 out of 5 are ready, right? So this is how you can see this kubectl get deployment. Now this internally deploys only pods, so you can see that kubectl get pods also shows up this, right? My deployment, there are 5 pods are running. Now similarly, if you would like to scale down, so we just need to reduce the number here to 3. Look at this. Now it is scaled down to 3. Now if you look at this, get pods again, now you see that there is terminating, which means that it is going to delete it. So the scaling up and then scaling down is so easy, team, just like a matter of seconds. We could scale up our infrastructure, application infrastructure, not the underlying infrastructure. Basically, the application infrastructure can be scaled up or scaled down easily based on your hardware resources available. So this is why we use Kubernetes. Again, this is one of the reasons scaling up is easily, and it manages the resources also very well. Now you understood scale up, scale down, and the deployment also. Now let's try to access this. As we discussed, the service concept is also acting as a load balancer. Now let's try to expose this deployment, and then we'll try to access it. Similar way, team, we need to create a service. The service is now going to act as a front end for all the pods in the back. kubectl expose, right, deployment mydep, right? We can give a port number here is equals to, the port number is 3000, team, the application port number which I'm giving it. Now type type is equals to node port. Again, this is what I'm giving it. Okay, so let's look at this, what exactly it is going to do it. Now it says that service my deployment created. Look at this kubectl get svc, right? You can see that my deployment service is available, and this is available at the port number called as 32403. Okay, so let's access this and we'll see that whether we are getting a response or not. Oh god, we got the response. Good. Now you can see that says that this is my version 1 app and the container ID, nothing but your pod ID, team. This is the pod ID. Basically you can watch this last 5 or 6 digits. Now let me refresh this. As I told that the service acts as a load balancer, right? If you want to look at the backends for this particular thing, kubectl get endpoints for this particular service. If you look at this, team, I'm getting the endpoints. EP stands for endpoint for my deployment service here. Now you can see that the backend is this. There are 3 pods that are running it. Look at that, kubectl get pods -o wide. Look at that, these are the pod IPs, right? 10.244.7, and then this one other 7, 2.7, and 244.1.8. So this is how you can think that these are the backends for my particular service. Now I'm sending a request into this particular service. Now you can see that this is the pod ID, the response we got it from 2H7SJ. Now if you go and refresh it, it got the request to a different pod. Now if I keep on refreshing it, it got to a different pod, right? I'm accessing only one URL, but it's keep on rotating the request, which means that the service is acting as a load balancer here. So this is how you need to think about the deployments and services in your Kubernetes cluster. This has a lot of other features also, team, but this is where I'll stop with this. I mean, this is how you can deploy a pod, you can deploy a controller, you could expose them and access the application in the browsers or the end user, you can call it, right? This is how we deploy it. Now there are a lot of other features and concepts basically, but we can get into them later. But this is what for a quick demo that I hope you guys understood now, how to deploy a pod, how to deploy a group of pods, and how do I access them. This is the simplest way to deploy it. Now finally, let's get into the things here, and then let's have a quick comparison why I need to use Kubernetes over the Docker Swarm, because Docker Swarm is the competitor, the side-by-side running competitor for Kubernetes, but still Kubernetes is the best one when compared to the Docker Swarm. People do use it. So here it is. The Docker Swarm basically has no auto scaling, whereas Kubernetes can do auto scaling. Of course, we did not demo that, we did a manual scaling only, but there is a possibility, or we could implement auto scaling in Kubernetes cluster. Now implements a CNM container networking mode. Docker comes up with the default, or Docker Swarm comes up with the default networking drivers or networking solution installed in it, the cluster. But whereas Kubernetes does not come with the default networking solution, but this is where it implements something called as container networking interface, where you could plug in various networking solutions, whichever is required based on the number of features if you would like to go for it. Now this is another feature. Kubernetes is pluggable. It's pluggable at the network solution side, it's pluggable at the container engine side, which means that not only the Docker, we could use the Rocket, or various other things we can use it, CRIO or Containerd, various things we could use it as a container engine for the Kubernetes backend, the container runtime. But in Docker, you just have to stick to the Docker itself. So there is a good community support. Both are open source mostly. So the good community support for your Docker Swarm, whereas Kubernetes is a great active community. We have it because of its huge demand in the market right now. There's a lot of active support which is provided over the community. Now the Docker has a limited APIs. Since you saw that the Kubernetes has an API server, Kubernetes APIs are much more richer when compared to your Docker APIs. So limited APIs, the more number of APIs and more solutions we have within Kubernetes. And coming to the deployment structure or production scale, Docker Swarm does not have much. This one, Docker Swarm introduced in 2017 or so, whereas Kubernetes is there from 2014 in the markets. It has matured in the production deployment, so we can use it easily in the, and we could rely on the Kubernetes in the production scenario always. That is why we should use Kubernetes over the Docker Swarm. This is a quick comparison team, but everybody does their own. So go for it and then try to find more about the differences between the various container orchestration platforms. Use it. Now, finally, the why CKA. We talked about various things again. Just to quickly summarize, we talked about why containers, what is the purpose of containers, how containers helps us. Then we try to understand container orchestration, and then why does a container orchestration required? How does Kubernetes help you with it? What is Kubernetes Architecture, Kubernetes Terminology, and then we saw a quick demo. Then finally, we compared with the other orchestration tool also. This is a quick summary that we did it so far. Finally, this course is mainly about the CKA team, the Certified Kubernetes Administrator, which means that we take you through, or we walk you through complete certification standard course, and we will help you get succeeded in your certification as much as we can. We would teach complete certification standard course and technology completely for you. So please look into it. And Kubernetes is exploding. That's what the CKA says. You know that from last 1 year, we saw that the 75% growth already. So if you have a CKA certification in your resume, it adds a lot of weight to your resume, and then you could be, one of the champ in the market right now. So that is why we say that learn the technology, but do the certification along with it, which will add more weightage on your CV or resume, we call it. So that will help you always in this one, and we would help you completely, to make you the certification standard, and you have to take your certification exam. Just for a glimpse, this is a practical oriented session, no multiple choice. This is all scenario based. You should resolve the issues which are given by the examination center examination, which is from the CNCF based on the things. So you should have to do it. Just for example, that's it.